Welcome to Lecture 3, Trigonometry. In this lecture, we're going to learn how to use Pythagorean Theorem to find a missing side in a right-angled triangle when you know two sides already. We're also going to use Sohcahtoa to find a missing side in a right-angled triangle when you know one side and one of the angles. And we're also going to use inverse trig ratios to search for one of the angles if you know two of the sides of a right-angled triangle. So first, let's begin with Pythagorean Theorem. Recall that Pythagorean Theorem, the formula is a squared plus b squared equals c squared. And there's also Sohcahtoa. Both of these can help you determine the side lengths and angles in a right triangle. So we're going to start with Pythagorean Theorem, which is a squared plus b squared equals c squared. Now we use Pythagorean Theorem when we have a right angle triangle and we know two of the three sides of that triangle and we're searching for the third side. Okay, so I'm just going to write that down. Pythagorean Theorem which is a squared plus b squared equals c squared. So you use this when you know two sides in a right triangle. So that means one of the angles is 90 degrees, and you'll know that because you'll see that there's a square in one of the angles that shows you it's 90 degrees. And you're looking for the third side. All right, now in Pythagorean Theorem, we have an A, a B, and a C in the formula. Now the C is the most important one, and for that we need to know which of the sides is which. Okay, so for C, what's very important is that C is the hypotenuse. And the hypotenuse is the longest side. Okay, sometimes you can't tell which side is the longest, so if you imagine this little square that's in the corner, you can imagine it as a little arrow pointing to the hypotenuse. So this is the hypotenuse over here, so this is my C. And that's the most important thing to recognize when you're using Pythagorean Theorem, is you have to look for the hypotenuse, and that is your C. Okay, the A and the B, it doesn't matter which one is which, as long as it's not the hypotenuse. So I can call this one A and this one B, or vice versa, it doesn't really matter. Okay, so I'm going to use Pythagorean Theorem now to solve for my missing side. So I'm going to start with the formula, a squared plus b squared equals c squared. I'm going to sub in the values that I know. I'm not going to use, I'm not going to input my units for now. I'll put them in at the very end. So my a is 3 squared. Since the 3 is not negative, I don't really need to worry about brackets, but if you want to, you could put the brackets in. It doesn't make a difference. Plus b squared, so b is 4, equals c. Well, c is labeled as x in my diagram, so I'm going to call it x squared. Okay, so I'm solving for x. So 3 squared is 9, plus 4 squared is 16, because 3 squared means 3 times 3, which is 9. 4 squared means 4 times 4, which is 16, equals x squared. 9 plus 16 is 25, equals x squared. We're solving for the x, so we need to get rid of the squared. So do you remember we need to get rid of the squared, we do the opposite of squaring something, which is square rooting. So I'm going to just rewrite the equation in the correct order. So I'm going to put the x squared on the left because it looks a little nicer that way. I'm going to square root both sides, but remember we need to put a little plus and minus in front of the square root sign. So we're ending up with x, because the square root and the squared cancel out, equals plus or minus 5. All right, so it looks like we're done. We have an answer of plus or minus 5, but because this is sort of like a word problem, there's a diagram that goes with it. We need to look back at the original question and make sure we're answering the question correctly. It's asking us to solve for x, which is the missing side in the right angled triangle. We know that side lengths can't be negative. That doesn't make any sense. And we know that the other sides have units of centimeters, so the side length of x must be in centimeters as well. So I'm just going to rewrite this as x is equal to 5 centimeters. And that's it. Okay? So all that we did was we solved for x using Pythagorean theorem. We made sure to know which side length was our c, the hypotenuse, and then we solved for the missing side. So let's do this again with part B. So for part B, we have to label our sides to begin with. So we're going to say our C is this longest side of the right angled triangle. We can imagine that this is an arrow pointing to that longest side. So this is our C, our hypotenuse. And then A and B, it doesn't matter which one is which. So I'm going to say this is our A and this is our B. Okay, but you could switch them around. It doesn't really make a difference. Okay, so for this question, we're going to start off again using Pythagorean theorem. So we have a squared plus b squared equals c squared. And I'm going to sub in what I know. My a is x this time. So I'm going to replace a with x. My b is 2.8. And my c is 3.6. Sometimes people forget to put in the squareds, so just make sure you're remembering them or the whole question will be incorrect. All right, so I'm trying to solve for this x over here, so I need to bring the 2.8 squared to the other side of the equal sign. So I'm going to leave my x squared where it is. I'll leave my 3.6 squared where it is. And the 2.8 squared used to be positive. Now that I'm moving it to the other side of the equal sign, it becomes negative. So now I can just simply type this on my calculator. So on my calculator, I'm just going to type 3.6 squared minus 2.8 squared. And I'm left with 5.12. Okay, now I'll square root both sides. And remember the plus or minus. So I'm left with x is equal to plus or minus, I'm going to type in the square root of 5.12 on my calculator, and I get 2.2627. I wasn't asked to round to a certain number of decimal places, so I'll just leave it as 26. The number after the 6 was a 2, so the 6 doesn't get rounded up, it stays as a 6. I have to look back at my original question and realize that there's no such thing as a negative side length. So I'm going to rewrite this as x is equal to 2.26. And then I'll take a look at the units, which is meters. Okay, so at this point I recommend that you pause the video and complete part C on your own because it's very similar as the other two questions we just did. Once you're ready to continue, just continue on with us. Okay, so for this one in part C, I'm just going to label my sides again. So I have my right angle on this corner this time. It points to my hypotenuse, which is always C. My other two sides don't matter which one's which, so I'm going to label this one A and this one B. Okay, so I'll start with Pythagorean theorem. A squared plus b squared equals c squared. My a is 2.47. My b is x. And my c is 6.78. So I'm trying to solve for this x, so I'm going to bring the 2.47 squared to the other side of the equal sign. Right now it's positive, so when I move it over, it's going to become negative. Now I'm just going to type this up on my calculator. 6.78 squared minus 2.47 squared. And I get 39.8675. Now I'm going to square root both sides, remembering the plus or minus in front. I end up with x is equal to the square root of 39.8675, which is 6.314. So my 1 is going to remain a 1. It won't get rounded up to a 2. I'll put this plus or minus here just so that you recognize that there should really be a plus or minus, but because in my diagram x is representing a side length, there's no such thing as a negative side length, so I'm just going to write my answer as 6.31. Take a look at the units, should be in kilometers. And that's all. All right, so that was question 1. Let's move on to question 2. So in question 2, we're going to be using Sohcahtoa. So I'm going to write this out on the side here. Sohcahtoa. Some of you may have heard this mnemonic before. Some of you, this might be brand new. So I'm going to explain what this means. On your calculator, you'll see 3 different trig buttons. One of them says sine, the other one says cos, and the other one says tan. Now the S, the C, and the T stand for those 3 trig buttons. So if I write the first equation here, what this means is sine of an angle, now I'm going to represent my angle with this Greek symbol theta, is equal to the opposite side over h, the hypotenuse. Likewise, for cos, I would say cos of my angle theta is equal to A, which stands for adjacent, over H, which is hypotenuse. And then for toa, I would say tan of my angle is equal to opposite over adjacent. Okay, so right now all of this looks kind of strange if you haven't done this before or if it's been a long time. What we want to do to begin is label our triangle, this time labeling it with opposite, adjacent, and hypotenuse. Okay, so in the previous question we already talked about what hypotenuse is. The hypotenuse is always the longest side of the triangle, and it's always opposite of the 90-degree angle. You can always imagine the little box over here to be part of a arrow that points to the hypotenuse. So this over here is the hypotenuse. Okay, when we're using Pythagorean Theorem, a squared plus b squared plus equals c squared, the hypotenuse is always the c value in the equation. Here we're not using a, b, and c anymore. We're using opposite, hypotenuse, and adjacent. So those are the 3 sides that we're going to label in our triangle instead of a, b, and c. Okay, so the hypotenuse is still the side that's opposite of the 90-degree angle, which is the longest side of the right angle triangle. Now we need to label our opposite and our adjacent. So let's start with opposite. So to label the opposite side, you just need to know which angle it is that you either know or you're looking for. So in this case, we know this angle here, the 32-degree angle. So the opposite side is opposite of the 32-degree angle. So it's not the side that's touching it over here, it's opposite of it. So it would be over here. Opposite. So it's opposite of the 32-degree angle. Okay, so opposite of the 90-degree angle is hypotenuse. Opposite of the angle that we know, or the angle that we're looking for, is the opposite side. And that just leaves us with one side left, which is called the adjacent. Adjacent just means next to. So it's the side that's next to the 32-degree angle. It's touching the 32-degree angle. It's not the hypotenuse though, because you can see the 32-degree angle touches 2 sides, the hypotenuse side over here and this side over here. So the adjacent side is just the one of those 2 that is not the hypotenuse. Okay, so I'm just going to put in the word adjacent right here. All right, so now we have our adjacent side labeled. So we have opposite, hypotenuse, adjacent, all labeled. The next thing that we're going to do is take a look at Sohcahtoa to decide which of those 3 equations is it that we're going to use. Okay, so when you look at the labeling that you've done on this right angle triangle, you want to identify which is the side that you know and which is the side that you want to know. So in this question, I know the 19 centimeter side length. So that's my hypotenuse. I know the hypotenuse. And which is the one that I'm looking for? Well, the question's asking to solve for the unknown side lengths, and it labels one of the side lengths as A. That's the one that it's asking me to find. The other side length, the one on the bottom that's labeled as adjacent, has not been asked for at all. The question's not asking me to find it. It's only asking me to find side A. So if I'm looking for side A, that would be my opposite. Okay, so your first step in these questions is to label adjacent, opposite, and hypotenuse. Your second step is to identify which is the side that you know. In this case, it's the hypotenuse because you know it's 19 centimeters. And which is the side that you want to know. In this case, it's the opposite because they asked us to find A. Now you'd go back to Sohcahtoa to identify which of those three equations is it that you're going to use that has an O in it for opposite and an H in it for hypotenuse. O and H, that would be right here. So that's telling us that we're going to use sine to solve this question. All right, so I'm going to write that out. I'm going to say sine of my angle. My angle is 32 degrees. Is equal to the opposite side. Well, the opposite side is A over the hypotenuse, and the hypotenuse is 19. Again, I'm not going to include the units right now, the centimeters. I'll put those in at the very end. Okay, so now we're trying to solve for A. So one thing we can do if we have a fraction and we're trying to solve for something, I find the easiest thing to do is to cross multiply. So sine 32 degrees right now doesn't look like a fraction, but to make it a fraction, we can just put it over 1. That doesn't change anything. So now I'm going to cross multiply, which means I'm going to multiply diagonally. So I'm going to multiply A times 1 and 19 times sine 32. So when I multiply A times 1, I get A. And then I have to remember to put in my equal sign. And now I'm multiplying 19 times sine 32. To do that, you just simply write 19 sine 32 degrees. Okay, now on your calculator, you can just type this up, 19 sine 32 degrees. So 19 sine 32. Now, on your calculator, you might notice that there are different modes of your calculator, and degree mode is the one that we're using in this course. So you'll see that the angles that we're working with are always in degrees. So you want to make sure that your calculator is in degree mode. Oftentimes you'll see a little D on your calculator typed up somewhere. Usually it's near the top of the screen. You want to make sure it says D. It doesn't say G. It doesn't say R. Those are not the correct modes, and you'll get an incorrect answer if you use those. Okay, so make sure you know how to check that your calculator is in degree mode. Now, when you type this on your calculator, you should be getting 10.0684 with more numbers afterwards. So it was 0684. I'm going to round it to 2 decimal places. So 06, there's an 8 following it, so the 6 should get rounded up to a 7. Now I can take a look at the units on my triangle, and I see that 19 is in centimeters, so this must be in centimeters as well. So A is equal to 10.07 centimeters. Okay, and that's how to solve for an unknown side length when you know one side length and an angle. You would use Sohcahtoa, as long as you have a right angle triangle, which is what we'll see in this course. Okay, so if you feel good about this, you can continue on to B and C, pause the video, and then continue back with us when you're ready to go. I'm going to continue with B now. So in part B, we're going to start by labeling our 3 sides. So I have my 21 degree angle, my right angle. So we'll start with the right angle always points to the hypotenuse. So this is my hypotenuse. The 21 degree angle, so the angle that we know, is opposite of the opposite side. And the side that's left over, the one that's adjacent or touching the 21 degree angle, is the adjacent side. Okay, now we're going to identify which side is it that we know and which side do we want to know. We know 14 meters is the adjacent side. That's the side that we know the length of. And the side that we're looking for is B, which is the opposite. So if we write Sohcahtoa, which of these is the one that we're going to use? It would be the one that has an O in it for opposite and an A in it for adjacent. So that would be TOA. Okay, so let's write out the formula for TOA. It would be tan of the angle is equal to opposite over adjacent. So let's fill in everything that we know. Tan, our angle is 21 degrees, is equal to the opposite side, which is B, over the adjacent side, which is 14. To solve for B, we're going to cross multiply, so I'm going to put a 1 underneath the tan 21 degrees. And now I'm going to multiply B times 1, which is B, is equal to 14 times tan 21. I like putting the 14 right in front because then I can type this on my calculator all in one shot. 14 tan 21 degrees. So on my calculator, I'm going to type this 14 tan 21, making sure my calculator is in degree mode. I see a little d in there. Equals, and I get 5.374. I'm going to round this to 2 decimal places. The number after the 7 was a 4, so I'm not going to round my 7 up to an 8. I'm going to leave it as a 7 because the number after it is less than 5. All right, I'll take a look at my diagram again, and I can see that the units were in meters, so I'll enter meters here. And that's it. Okay, so again, if you feel like you're good with all of this, go ahead and try part C on your own, and then rejoin us when you're ready. So I'm going to start labeling the sides again in part C. Opposite of the 90-degree angle is the hypotenuse. Now in this question, I didn't clearly indicate which side is the 90-degree angle, but you can tell that this side here is 90 degrees. And so it's pointing at the hypotenuse. So this would be the hypotenuse. Next, we are given this angle 49 degrees. Opposite of that is the opposite side. And now we're left with the adjacent, which is touching the 49-degree angle or adjacent to it. Okay, so we can now move on to writing Sohcahtoa. And then now we can identify which is the side that we know, which is the side that we want to know. So we know 27.3 kilometers, that's our adjacent. And we want to know side C, that's our hypotenuse. So we're looking for the equation that has an A and an H in it. This time that would be Ka. So let's write out the equation in full first. Cos of the angle theta is equal to adjacent over hypotenuse. And now let's fill in everything that we know. The angle theta is 49 degrees equals adjacent, which is 27.3, over hypotenuse, which is C. So next, I want to get rid of this fraction, so I'm going to cross multiply. So I'm going to put this over 1, and now I'm going to cross multiply. So I'm going to do 1 times 27.3, which is 27.3, is equal to C times cos 49 degrees, which would be C cos 49 degrees. And I'm trying to solve for C, so this time it looks a little different because in previous questions, when I cross multiplied, the variable that I was looking for was on its own. But this time, the C is next to cos 49 degrees. So we just need to do one more step to solve for that C. Right now, C is touching cos 49 degrees. When two things are touching each other, there's an invisible multiplication sign there. So to get rid of the cos 49 degrees, we have to do the opposite of multiplying. We need to divide. So we're going to divide both sides by cos 49 degrees. And now what are we left with? I'm going to put I'm going to cancel out the cos 49s. I have c. I'm going to just rearrange my equation so the c is on the left side because it looks a little bit nicer that way, is equal to 27.3 divided by cos 49 degrees. Now I'm going to just type this onto my calculator. 27.3 divided by cos 49. Make sure you're actually typing these questions up on your calculator so that you know how to use your own specific calculator. I get 41.612. If I round it to the nearest hundredth, that would give me 41.61 because following the 1 was a 2, so that number is smaller than 5 and I don't have to round my 1 up. I go back to my question, take a look at the units, and I see that they're in kilometers. So I'll just put in kilometers and I'm all done. All right, D. This is the last question of this type. All right, so let's go through the whole process all over again. We're going to start by labeling our three sides. So our 90-degree angle is right here. Opposite of that angle is the hypotenuse. Our angle that we know is over here. Opposite of that angle is opposite. And then our last side is the adjacent. We're going to write out Sohcahtoa. Then we're going to identify which are the sides that we know, which is the side that we want to know. So we know 121 meters is our opposite side. We want to know side D, which is our adjacent side. So we're looking for the equation that has O and A in it. So that would be tan. Tan has O and A in it. Now we're going to rewrite the equation. So we have tan of the angle is equal to opposite over adjacent. And now we're going to substitute all the values that we know. So theta is our angle, that's 32 degrees, equals opposite, which is 121, over adjacent, which is D. Now we're trying to solve for D. We want to get rid of this fraction, so we're going to turn this into a fraction so we can cross multiply. So we're going to multiply 1 times 121, which is just 121, is equal to, now we're going to multiply D times tan 32. And that just gives us D tan 32. We're trying to solve for D, so we want to get rid of that tan 32 degrees. Remembering that there's an invisible times sign here. To get rid of the tan 32 degrees, we divide both sides by tan 32 degrees. And now we're left with tan 32 degrees cancels on the right side. So we have D left over on the right side equals 121 over tan 32 degrees. I'm just going to rearrange it so D is on the left side instead so it looks better. And now I'm going to solve for D. I'm just going to type this onto my calculator. So I have 121 divided by tan 32 equals, and I get 193.64. D is equal to 193.64. I take a look at my question again, and I see the units were in meters, so I need to remember to put meters here. And I'm all done. Okay, so to recap, you use Sohcahtoa when you know one of the angles and one of the sides, and you're looking for another side in a right angle triangle. All of these questions will be done with right angle triangles because that's the only way you're able to use Sohcahtoa. A right angle triangle is the only way you will have a hypotenuse. Without that, there wouldn't be a hypotenuse, so you wouldn't be able to use Sohcahtoa. Okay, so let's move on to our last type of question, which is using inverse trig ratios. Now for inverse trig ratios, we're still using Sohcahtoa. But the difference is this time we're looking for an angle. And we know two of the sides. and it's still a right angle triangle. Okay, so these are all right angle triangle questions. So the process here is very similar to what we did before, except that you need to recognize that this time we're looking for the angle. When we think of Sohcahtoa, remember when we wrote out the formulas, the theta, that was the angle part. So there's an additional step that you need to do for these questions. But we're going to start off the same way as we did before. We'll start off by just labeling our three sides. So we have our right angle over here, which points at our hypotenuse. Now we have the angle that we're looking for. Okay, so in these questions, we don't know any of the angles. We're looking for an angle instead. The only angle we know is the right angle. This is the angle that we're looking for. Opposite of that angle is the opposite still. And that leaves us with the last side, which is the adjacent, the side that's touching that angle that we're looking for, the adjacent side. Okay, this time we're going to label the two sides that we know. We're going to highlight them. So we know 21 centimeters, which is the opposite side, and we know 33 centimeters, which is the hypotenuse. So now we're going to decide which one are we going to use, so, ka, or toa. So because we're looking for the angle this time, we need to know two sides. And those two sides are the ones that are going to help us decide which equation to use. We know O and H, so we're going to choose the equation that has O and H in it, which is the sine equation. So I'm going to write out the formula for SO. Sine of the angle is equal to opposite over hypotenuse. And now we're going to enter all the things that we know. Sine, now my angle was labeled as x, so I'm going to put an x in here in place of the angle, equals opposite, which was 21, over hypotenuse, which was 33. Okay, notice that the two units, centimeters and centimeters, they have to be the same. We don't have to enter them here, but we need to make sure they're the same, because since they're the same, they cancel each other out. If they were different, we would need to convert so that they were the same. Okay, so if one was in meters and one was in centimeters, we would need to convert one so that they were both the same as each other. Okay, so now we're trying to solve for this x over here. So how are we going to solve for that x? Well, what's strange here is that I normally ask you what operation is between sine and x, and because they're touching each other, a lot of people would think there's an invisible times sign here, right? But there actually isn't, because x and sine are not being multiplied by each other. Sine is actually a function. It's not a number or a variable. It's actually an equation or a function. So between sine and x, there's not an operation. The x itself is the angle. And anytime you're solving for an angle, you're going to need to use a special button on your calculator, which is an inverse trig ratio button. And that's why this topic is called inverse trig ratios. Most of the time, to get to an inverse trig ratio, you would have to hit the shift or second function button on your calculator, and then the trig function that you're looking for. So what we're going to do, I'm going to show you step by step how to solve for this x. I want to get rid of this sign. To get rid of it, I can't simply divide by sine. If I try to do 21 over 33 divided by sine on my calculator, I will just get an error. So I'm going to take this sine to the other side of the equation, but to do that, I need to use a special inverse trig button, which is called sine inverse. It just looks like it has an exponent of -1. I'm going to just delete these centimeters because they cancel out. And then the 21 over 33 just stays where it is. I'll put it in brackets. So on my calculator, I click shift and then sine. And then it appears on my calculator as a sine inverse, or sine to the power of -1. And that's the same as moving your sine to the other side of the equal sign. And then I'm going to write 21 over 33 and I get 39.521. I'll round it to the nearest hundredth. There's a 1 following the 2, so the 2 stays as a 2. And now I have to think about what my units are. So that x was representing an angle, so the units are in degrees. Okay? Because this was sine, when I move it to the other side of the equal sign, it becomes sine inverse. If it was cos, and I moved it to the opposite side of the equal sign, it would become cos inverse, and tan would become tan inverse. Alright, so if you feel good about this question, move on to part B, pause the video, and then continue when you're ready. We're going to move on right now to part B. So let's do the process over again. We're going to start by labeling our 3 sides. So opposite of the right angle is the hypotenuse. Opposite of the angle that we're looking for is opposite. And then the remaining side, which is the side that's adjacent to or touching the angle that we're looking for, is the adjacent side. I'm going to write out Sohcahtoa. And then I'm going to highlight which are the 2 sides that we know. Because we don't know the angle, we must know 2 of the sides. We know 11 meters is the opposite side, and 17 meters is the adjacent side. So we're going to choose the equation that has O and A in it, which would be TOA. So now I'm going to write the formula for TOA, which is tan of the angle is equal to opposite over adjacent. And now I'm going to sub in everything I know. So my angle is labeled as x equals opposite, which was 11, over adjacent 17. Double checking that the units were both in meters, so I don't need to convert anything. I'm now going to solve for x by taking my tan and moving it to the opposite side of the equal sign, which means tan becomes tan inverse. 11 over 17. And I'm going to put it in brackets just to make it more clear that it's all together. Now I'm just going to type this on my calculator. Tan inverse. So I'm hitting shift tan. You might hit second function tan. On some calculators you click the tan button twice, so it just depends on your own calculator. And then 11 over 17. I'm putting 11 over 17 in brackets, or if you have a fraction button, you can use that as well. Equals 32.905. My 0 is going to get rounded up to a 1 because it's followed by a 5. And then I take a look at the units. Again, x is an angle, so my units should be degrees. And that's it. Okay, so we only have 2 more questions like this. Again, if you can, go ahead and try these on your own. Pause the video and then continue when you're ready. We're going to move ahead right now. So our 90-degree angle is right here. That makes this side our hypotenuse. Our angle that we're looking for is right here, so that makes this side our opposite, leaving our remaining side as the adjacent. Now I'm going to write Sohcahtoa. I'm going to highlight the 2 sides that I know. I know the hypotenuse and I know the adjacent. H and A, that would be Ka. Now I'm going to write out the formula for Ka. So cos of my angle is equal to adjacent over hypotenuse. Notice I skipped that step where I wrote the formula. I'll write the formula right here in case it's helpful. Cos of the angle is equal to adjacent over hypotenuse. Okay, the angle was x, the adjacent was 27.3, and the hypotenuse was 41.7. Now I'm trying to solve for x, so I need to move my cos to the opposite side of the equal sign, which means I'm going to use that cos inverse button of 27.3 over 41.7. So I'm going to type this on my calculator. Cos inverse 27.3 over 41.7, and I get 49.104. 49.10. My 0 doesn't round up because it's followed by a 4. I'm looking here for my angle. X is an angle, so the units are degrees. All right, now I'm on to my last question in this lecture. So again, I'm going to label my sides. This is my 90-degree angle, so this would be my hypotenuse. This is the angle that I'm looking for, so this is the opposite side. And my remaining side is the adjacent side. So I'm going to write out the formula. Sohcahtoa I'm going to highlight the two sides that I know. So that would be my opposite side and my adjacent side. So O and A, that would be TOA. So I'm going to write out the formula. Tan theta equals opposite over adjacent. I'm going to sub in all the values that I know. My theta is labeled as X equals opposite, which is 119, over adjacent, which is 149. Notice the 2 units of the sides are both meters, so they cancel each other out. I don't need to convert anything. And now I'm solving for X. So I'm going to take this tan, move it to the other side of the equal sign by using the tan inverse button of 119 over 149. I'm going to type this on my calculator. Tan inverse of 119 over 149. And I get 38.612. My 1 was followed by a 2, so it doesn't get rounded up. And my X is representing an angle, so the units for the angle should be in degrees. So that's in degrees. And that's it. That was the final question of this lecture. So hopefully that was all helpful. Thanks so much for watching, and see you next time.